basically myself, Sunandan Ghosh, and Professor Paula Shde from Computer Science Department will be your instructors for this third module. And I guess a tentative structure has already been shared to all of you. I will take care of the economic theory, and Dr. Dev will take care of the AI part of it. So, without delaying much, let me start. Now, as you can see on your screen, by the way, if you have any queries, immediately stop me and ask the question. That's how I operate. Because if you just raise a hand, it might not be visible to me because I am concentrating on the slides during that time. So I'll be having a different window in front of me. So if you have any queries or any doubt in between, or say my voice is, I become inaudible or the slides are not uh, popping up correctly, please let me know anytime. So the topic that we'll start with is, as you can see, commodity pricing. To give a prelude of it, those of you present here have done at least HS 20001, which is economics. You know, there exists demand and supply, and pricing depends on that. Added to that, the pricing itself depends on two more things. One is the market structure. Now, what is market structure? As we move on, this couple of lectures, these different categories of structural parts will become more clear to all of you. For the time being, I'm just giving you some jargons, if I may say so, like perfect competition, duopoly, oligopoly, monopoly, monopolistic competition, near perfect competition. You can think of basically whether as a seller of a particular commodity, you command price of that commodity in the market. So it's basically a 0 to 1 continuum. So if you have no control over the price, you are a mere price taker, will you in the perfect competition domain. But if you're the only seller and you can charge any price you like, you become a monopoly. Similarly, duopoly, when there are two firms, oligopoly, larger but little fewer number of firms, and so far so good. One more reason for which price of goods will differ, or the component on which pricing is contingent upon, is the type of the good itself. So if you're buying potatoes, whether you're buying from vegetable vendor 1 or vegetable vendor 2 does not make any difference. It's a homogeneous good. Potato here is potato there. Heterogeneous is a differentiated good, right? The smartphones that you use, they have different features. They are different from each other. The laptops that you use, right? Different varieties. You cannot say, I just bought a smartphone. You don't go to the market to buy, just I just want to buy a smartphone. You have certain features in mind, right? So these are the type of goods I'm talking about. Now, to first give you the simplest form of a structure is, if you have a demand schedule, if you have a supply schedule, then they will intersect. You have a price quantity combination that will, in economics jargon, will say clear the market, which means the plans for the agents are buyers and sellers, are realized simultaneously. It looks like this, and this is a very common picture available in any economics textbook, right? Now, what do I mean by that? Look, at a particular price, say P prime, the quantity demanded is much lower than the quantity supplied. It's visible from the simple graph in front of you. But they do not match. So at P prime, the quantity demanded and the quantity supplied are not matched. At PE, it matches. And hence we call it an equilibrium. And the funny thing is, we all economists are very happy when the equilibrium is reached. And most of the time, it's off the OFF, off the equilibrium that we operate. So to define this equilibrium thing, what we say, that the quantity that will be transacted, equilibrium quantity that will be transacted, is the minimum of quantity demanded and supplied at a particular price. So just I'm going back a slide. Look at the second bullet, quantity transacted. I'm giving P prime, right? And as you can see, out of those two minimum, XT, which is quantity demanded at P prime, is lower than XS, which is quantity supplied at P prime. The quantity transacted will be XD, right? So only at PE, which I'll call the equilibrium or market clearing price, these two things will match, which is quantity demanded and quantity supplied. And hence we say that a market clearing price is a configuration at which the plans means, what is a plan? I have this much budget, I'll go spend this much, and a supplier will say, okay, I have incurred so much costs, I need minimum this, so that to supply a particular amount of quantity, right? So these plans are matched. Now take for example, if you have a labor union, so market might not always be for commodities. Our lectures will always focus on commodities. But just to give a brief idea about equilibrium price, let me talk about a labor market where you have labor union. And they will say, our wage, what is wage? The price of labor. The wage will not fall, say, below a particular floor, wage floor, say W prime. Look at W prime, the labor supplied and the labor demanded will not match each other. So the minimum is the labor demanded, L naught. So only that much labor will be absorbed at a wage rate W prime, W bar, and this much, the distance between the labor demand and labor supply, the horizontal distance between those two schedules at W prime will give you the unemployment at that particular wage, right? So this is just an example. Now let's talk about the first way of determining prices. So the first structure that we'll study is perfect competition. Here, all the agents, whether you're a buyer or a seller, whoever, no one has any control over the market price. Because let's assume there are innumerable buyers and sellers in a particular market. It's the aggregate supply and the aggregate demand that gives you a schedule like say this, and a PE is realized. But the problem is everyone thinks that I cannot have any bearing on the pricing mechanism. Suppose I am a buyer. I think I will just buy so much small amount of that commodity. How can I have a bargaining power? So whatever the price is there, I'll pay the price, I'll buy. Same with the seller. Seller also knows he cannot charge anything more than what others are charging. And it's an automatic sort of a mechanism where the price is getting determined. And this is basically what we call the invisible hand in economic theory, which was coined by Adam Smith, one of the foremost, in fact, the foremost economist who wrote about invisible hand in the year 1776. So it's as old as that. Now, let me skip about these reason why there is a common mistake that only if you have very large number of buyers and sellers, only then you can have a perfectly competitive markets. But that's not necessarily true. The only thing is the agents should behave competitively. So I'm not delving into these reasons. So have a look when the slides are shared with you, and you will understand. So there is nothing big there. So let's have a simple problem. Uh, and throughout the series of lectures, I'll be using certain functional forms specific to a particular case so that it becomes uh, a sort of a substitute to, say, tutorial lectures, which are required sometimes. So I will plug in some examples, numerical or functional forms examples, mathematical examples, so that you can understand it better. Now, what is a demand function? Quantity as a function of price. So at different prices, how much I demand. So Q as a function of price. So the inverse demand function is nothing. I say price is nothing but a function of quantity. And look, that is how I have written. So price as a function of quantity, and I have given a very simple linear form, right? Look, we have the inverse relationship to capture the fact that we are dealing with normal goods. What are normal goods? The goods which follow law of demand. What is law of demand? Everything else remaining constant. So income, how many number of players moving in, going out, how many farms popping up, how many farms dying out of business, whether there are new economic policies. So everything remaining constant. Everything's remaining the way they are. If price increase, quantity demanded will fall. That's law of demand. Look, the moment you have a higher income, you can have more. So hence income is also part of that, other things remaining constant. So everything remaining constant, the unique relationship between the price and the quantity of a good. That's a negative relation. We call it a law of demand. And so far, what we start with is a good which is homogeneous. So whatever you sell and I sell are exactly the same thing. Potatoes, potatoes. That's it. And something here, I am using economics jargon. Please raise hand if anyone does not understand this word. Anyone who is not familiar with this word. Okay, Gyanaranjan. Look, returns to scale can be of three types: constant, decreasing, increasing. It is coming from the producer's side. Suppose you have a production function which says what? Output is a function of the inputs to production. Very simple. Fine. Suppose X is the vector of the inputs to production. Y is your output. Now, the moment you increase your inputs to production, say by lambda units, all the inputs by lambda units, how much your output will increase? There can be three possibilities. Suppose you increase it by lambda units, all the inputs to production, then your output can increase by lambda units. That is what we call constant returns to scale. It can increase by more than lambda units. That is what we call increasing returns to scale. It can increase by an amount which is less than lambda. That is called decreasing returns to scale. So what we are assuming here is a production function. The implicit production function is such that if you increase the inputs to the production function by, say, lambda units, your output can increase at max by lambda units. Is it clear? If not clear, stop me We can come back later. And suppose we are just assuming 2 farms, not necessarily very high number of farms. And you have a very simple cost function. So TCI is the total cost given a quantity Q such that it's CIQI. And a relationship, the C2, which is the farm 2's marginal cost, is greater than equal to C1 greater than equal to 0. Okay. What is the average cost? Average cost is total cost divided by quantity. What is marginal cost? Del TC del Q. Look, if I have a functional form TC is equal to CIQI, then both average cost and marginal cost will be the same, CI. So it's a very, very simple cost structure, the simplest form we can take. Now, how can we define equilibrium here? Now, what is equilibrium? Equilibrium is nothing but a pair of the quantity that will be supplied and the price that will be charged per unit of that. Now, for each farm, it will maximize its profit. And when that equilibrium price is realized, we have aggregate quantity demanded equal to the aggregate quantity supplied. So basically, we are talking about 2 farms. And this is what we call a triplet, which is the quantities supplied by the 2 farms. So Q1E, E small e stands for equilibrium, and the price. And what will be the objective function or the function which will be optimized so that we get the equilibrium values? Simple. At a particular price, what will be your total revenue? What is profit? Profit is total revenue minus total cost. What is your total revenue? Price into quantity. So PE QI for each farm I minus the total cost, which is CIQI, right? And so for each farm, what will you get? You differentiate this right-hand side of the objective function. PE, what is optimization part? Del pi I del QI, because QI is the choice variable that you have. Because we are talking about perfectly competitive markets, I know I will not have a bearing on the price myself, so I take the price as given. Though I'm contributing to the price without knowing it at the aggregate level, because I'm also a part of the system. So I'm that ith farm, and I think price is given. So my total revenue is PEQI. And what is my cost? CIQI, because total cost structure I have already defined here. CIQI. Now, if I maximize this, the first order condition, what will you get? PE equal to CI. You have differentiated it with respect to QI. Put it equal to 0. That's your maximization part. Second part, look, I have just considered 2 farms. So this first part, this point 1, this maximization problem, has to be done by both. From there, you get 2 parts, Q1 and Q2. Plug it back to the inverse demand function here, where Q is the total quantity supplied, but this consists of Q1 and Q2, 2 farms. So the price will be such that it will clear the market. Now look, you can have 3 options. Here, everything is determined by the supply side part. And the supply side part is captured by the total cost function. And in the total cost function, I only have a marginal cost. I do not have a fixed cost. And the variable cost is equal to my marginal cost, right? Now the question is, I can have 3 options. The price can be more than CI, equal to CI, less than CI. Now, if the price is less than CI, you will not produce. Why should you go and make loss? Because the price that you fetch per unit is less than the cost at which you're producing it. So that's why QI equal to 0. If price is more than the marginal cost part, then it will be infinite. Right? Every farm will produce infinite amount. That's also an indeterminate solution. So a determinate solution that you can get is only at P equal to CI. And if you go back, plug back these equilibrium values, what is this first part is nothing but the reason why I gave this particular supply side function or the supply function. Okay. Why the reasons are given here. Now, you have a unique competitive solution when price is equal to the cost or PE is equal to C1. Now, suppose two farms have two different costs as assumed. Then from where will you buy? The same good. You'll buy from the one who will offer you the lower price. And hence, there is no role of an inefficient farm here. If my cost structure is more, if I incur more costs while producing the same thing than you, I'll be going out of business. As simple as that. And hence you have an equilibrium. The only problem with this equilibrium is, and this is what we call marginal cost pricing. So the marginal cost of production is equal to the price that you can charge. Because it's the same good, you cannot charge more than your competitor. Everyone will buy from the one who offers a lower price. And what you can get is the equilibrium quantity supplied. Just solve for it here and you will get it. Okay. So there is no problem in solving this thing. The only thing that you can see from here is very simple. If you have a cost structure C1 and C2 for two farms, everyone will purchase from the first farm. So basically, there is no role of inefficiency in a competitive market structure. If you're inefficient, you will go out of business. As simple as that. And that is why when I relate it to practical policy making perspectives of governments across the world, everyone promotes competition. Okay. Now, remember we had assumed non-IRS technology. Why? Now, let's do something. What is IRS? The more I produce, the lower will be my marginal cost. Right? Remember from the definition. If I increase my inputs by lambda units, my output will go by more than lambda units. Which means the more I produce, my marginal costs will come down. A very simple way to formulate an IRS function is just to add a fixed cost. So the total cost function is F plus CQ. Even if you do not produce anything, Q equal to 0, the fixed cost will be there. So the average cost keeps falling. And that's a very simple way of modeling IRS production technology. Now the question is, if your price is less than your average cost, what is your average cost then? F by Q plus C. Because average cost is nothing but total cost divided by quantity. So average cost from this functional form, what you get F by Q plus C. So if your equilibrium price is less than F by Q plus C, you will make loss and you will not produce anything, Q equal to 0. If it is greater than infinity, clubbing this together, what you can get is there will not have any equilibrium. And why? Because just think intuitively. There are multiple number of firms, all facing a similar IRS production technology. Everyone will try to produce more so that their marginal cost comes down. Why? If the marginal cost is low, I can charge a lower price and share a more, I can enjoy a higher share of the market. I can have more customers. Now the question is, the plant or the farm with the largest plant size can produce the maximum amount. So it will have the least marginal cost, it will charge the least price, and it will outshine all other farms in the market, in the industry. So everyone else, except for that farm, will stay in the business. So we become a monopoly. So this perfectly competitive market structure fails. And hence, if we assume a production structure which is IRS, you cannot have a perfectly competitive equilibrium. So equilibrium will not exist. Now, any questions so far? Please raise your hand. Fine. No questions means no hands raised means no questions. Fine. Now we go to the other extreme, a monopoly. Here we only have one seller. And it faces what we say a downward sloping demand curve. So it's a normal good. We're in that domain. The most important thing of a monopolist is to estimate the demand curve. And that's it. Rest will be done by its profit maximization part. How? Let's again take a simple functional form. And look, we have not tweaked anything. It's a very generic form, an absolute generic form. You can produce a particular quantity and will choose a quantity that maximizes your profit. And this profit maximization tells you what? You will choose a quantity, a monopoly quantity, that's why this superscript small m, such that your marginal revenue equates to your marginal cost. Simple. No problem here. Now the thing is, here we say, is it a necessary condition or a sufficient condition? As you will see, it is necessary, not sufficient. Okay. Yeah. Anyone wanted to say something? I'm hearing a noise. If anyone has a question, please raise that. I'm just getting a noise, a feedback sort of thing. Might be technical. Anyway, now I'm just keeping these slides. I'll come back, but let me start with a very simple functional form. Suppose you face a demand curve A minus BQ, a downward sloping simple inverse demand curve, right? And you have a total cost function with F plus CQ square. That's a functional form, a generic functional form, ad hoc functional form that we are giving. Where F is the fixed cost, Q is the quantity that you produce, C is the marginal cost of production. Now, when you have your profit maximization, which is total revenue, which is P dot Q. So basically A minus BQ whole into Q, that gives you total revenue. And this gives you a total cost. And the first order condition will tell you that you will have a quantity that will solve your marginal revenue equal to marginal cost. And you have a quantity, equilibrium quantity, which you should be producing. Look, it depends only on the parameters. What are these parameters? A is the intercept term of the demand curve. B, the slope of the demand curve. C, the marginal cost of the demand curve, supply curve, the marginal cost of production. Okay. Now, when you plug it back to your inverse demand curve, you get the price. Again, in terms of the parameters of the model. Now, depending on the exact numeric values, so this is a generic form. And you can have the exact price depending on the values of A, B, and C. Now, what is your profit function? This is your profit function. Price into quantity, equilibrium. The equilibrium here is given by a superscript m because of the monopoly thing. Minus F fixed cost minus C QM square, right? And you plug back these values QM and P, the monopoly price and the monopoly quantity, in your profit function, and that gives you a form of this sort. Now, your profit maximization output QM is not necessarily only this part, but you have to see whether this value is positive or not, because this depends on a fixed cost. Look, the quantity that you produce is irrespective or independent of the fixed cost, but the total profit is contingent upon the fixed cost. Hence, you will produce a quantity if and only if a positive quantity, if and only if this part is positive, or f is less than this a square by 4 into b plus c. Now, if this part is negative, which means you have a negative profit, then you'll obviously not produce anything. So how will it look graphically? When f is less than this critical or threshold value, your fixed cost is somewhere. Irrespective of that, you will have a quantity and your price. But if your fixed cost is high enough, then your average cost is high. And hence, you'll not have an equilibrium. The quantity that you'll produce will be zero. Now, so far, we have talked about a monopolist and who charges a single uniform price to all the customers. But most of the time, what we see is if a farm has a power to set price, unlike a perfectly competitive farm, what it will do? It will charge different prices from different consumers. Take, for example, if you purchase Indian Railway tickets, if you want to travel in a non-AC sleeper, you pay lower price. If you want to go for a third AC, a little higher price. Second AC, even higher. First AC, exorbitant. You choose. But why a monopolist can charge? Look, Indian Railway is a monopolist. There is no other competitor for Indian Rail. So that's why I'm giving that example. Now, why is that? Because different consumers have different preferences. Or consumers have different characteristics. The only thing that the monopolist has to ensure is that no arbitrage happens. What is arbitrage? Arbitrage is the technical term for buying low and then selling at a higher price. So if the Indian Railway can stop you purchasing the same thing at a lower price and selling it to another at a higher price, then this price discrimination is possible. Yes, I heard something. This is the problem in this online mode. Suppose someone of you wanted to say something, but there is a technical issue. You could not say, your microphone is not working or anything. But in that case, drop a chat, raise your hand, whatever, if you need to have an observation or you have a query. Okay. Now, a farm can charge different price depending on different locations. Or it can charge different price on different categories of people. Or it can also have, that will be the second part of our this 2 lecture series on commodity pricing, that you produce the same thing but little differentiation. Take for example, a book publisher can have publish a Kindle edition, a paperback, a hardbound. In general, the Kindle edition is the cheapest, followed by the paperback, followed by hardbound. And it sells individuals to individual buyers, the paperbacks or the Kindle editions, but to the libraries, public libraries, institution libraries, the hard copies. Hardbound. Hard copy means hardbound. Now, suppose the monopolist can identify these two markets, whether these two markets are geographically different or they can be different, like a market, same place in the same domain. So no geography, no spatial attribute, but maybe the customers have two parts. You have, let's talk about books, printed books. You have teachers and you have students, and you give a little more discount to students. Now, if you can determine these two markets or the two types of buyers, then how much will you charge? Look, the profit maximization problem will remain the same, only with two different quantities, because I know I'll be charging two different prices, and two different prices will be clubbed with two different quantities. But to produce these two different quantities, I'm having the same cost structure. And that is why look at the optimization function. Total revenue from market one, total revenue from market two, market one where you sell Q1, market two where you sell Q2. The total cost Q1 plus Q2. Okay, this comma will not be there. Rectified. Now, you will have two different the choice variables for the farmers, Q1 and Q2. And now the two first order conditions will come, which give you MR equal to MC for each market. MR for ith market, but the MC is common. And these two marginal revenues are contingent upon what we have studied in normal microeconomics or HS20001 to elasticity of demand. What is elasticity of demand? What is the sensitivity of quantity dependent on an unit change in price? So del XX divided by del PP. So if the two markets have two different elasticities, that will be captured by the two marginal revenues. Because by definition, MR is equal to MR1 is equal to this, and MR2 equal to this. And now, graphically, you can think. So you have two markets with two different prices. but your marginal cost is the same. That comes from your cost function. So you will obviously have a higher price with less elastic demand. Why? What is less elasticity? Where with change in price, the quantity demanded does not change much. Take for example, I just give you two examples. One, you are talking about petroleum, fuel, and you have two categories of people. And suppose, unlike India, the seller is a monopolist. In India, I have too many types of sellers of petrol. Indian Oil, HP, BP, Reliance, too many players. There are players whose name also we do not know. But suppose there is one unique seller, monopolist, who controls the entire supply of petrol or say automobile fuel in the India market. He will immediately do one thing. He will find whether you are coming with a private car or not. Because the rich people, rich as in you can have your own personal vehicle, will always come with a less elastic demand. So even if the prices rise, they will still go and fill their car. And the public transport people will come. And it is that public transport, say buses or trucks or any other non-private vehicles, which will have more sensitivity to prices. And immediately we can identify the two different types of customers with two different sensitivities and will charge higher price from those whose elasticity or whose reaction to price rise is less. Okay. Now we also have two more types of monopolies. One is a cartel, one is a multi-plant. So far, look, when I'm talking about a farm, I'm just assuming that the farm has only one plant. On the other hand, if you look at uh, very simple like cement production, so there is a very known name in this part of India, Ambuja cement. It's produced almost like 17, 18 plants in the country, if not more. So those are called multi-plant monopoly. And something what we call a cartel. Cartel is an organization which has too many farms under its ambit. So the cartel is that organization that will say to each member plant farm that only this much you should produce so that at aggregate we can charge this price. So this is basically too many farms. Yes, someone. Other, Dr. Mitra?
Yes, yes.
Yeah.
Yes,
You're
you're
not.
telling something?
No, basically I thought that you might be having a point or so.
No, no, I just joined. Like I
Okay,
was
okay,
off
okay,
the
okay.
meeting. I just.
Okay, okay. Now, so basically this cartel is nothing but, as you can see, a number of farms who cannot have a market power of its own will come together, form a club, and operate as a single entity only for the pricing part. Now, the only difference between a multi-plant monopoly and a cartel is the multi-plant monopoly. It's also different plants or different farms, but having a single owner. And the difference is very important because in a cartel, a particular farm cannot be told that you stop production because he's just a member. can request or you can finalize a particular level of output for each farm under a cartel. But you cannot say that quantity should be zero. But in a multi-plant monopoly, because all the plants are owned by the same owner, he can actually shut down the production of a plant. So that's the only difference. So in a cartel, again, the quantity is to be decided. But in a plant, not only the quantity, the number of plants that will operate, that is also a decision variable. So look, we are skipping this particular demand side problem at bay. Because so far, as you can see, we have not said anything about the consumers. We are just assuming that the consumers are price takers. And that is why, look, the demand curve, we have not changed. We have just used a simple linear downward sloping demand curve. So we have not tampered with that. We will tamper with this when we have differentiated goods. Under homogeneous goods, we have not tampered with it. Now, let's assume there are n plants or farms, each producing a value of output Qi, such that summation Qi, I running from 1 to n, becomes your capital Q, right? And the functional forms are keeping the same. And you have the marginal cost and the average total costs, right? So I'm not tampered with anything so far. Now, what will be your optimization part? The part is, instead, so far what we have done, ith farm optimizes its own profit. But when it comes to cartel, it needs to maximize the sum of profit of all the n plants. That's the difference. Now, let's assume pi I, which is a function of Qi. Pi I is the profit, Q is the quantity, I is the ith form. And Q is summation of Qi. Now you have profits, aggregate profit, which is summation pi. And you need to maximize this summation pi. Just you put it, the first is price, this part, sorry. Yeah, A minus BQ, that's your inverse, that's a price function, where capital Q is nothing but summation Qi. So total revenue is what? Price into summation Qi minus total cost for all the firms together. So it's basically joint profit maximization. And you will have n number of first order conditions, because if there are I farms, each one having Qi as the choice variable, then you have n number of FOCs. And what you get is a very simple, where the marginal revenue comes from the inverse demand function. Marginal cost comes from each and every farm. And when you solve for it, you'll get the total quantity. Plugging it back, you get the price. And now if all the farms are alike, then each farm will be what? Put n equal to 1. Suppose it's only one farm. Put n equal to 1. What is the result? A by twice B plus C. Look, that is exactly the monopoly outcome. Right? So that's the cartel part. For a multi-plant monopoly, where it can actually shut down a number of plants, or at least one plant, not only saving some variable cost, but also some fixed costs associated to that plant. So n, how many number of plants, is also a choice variable. So the question now we'll be asking is, what is the profit maximizing number of plants? Okay, so that's now look, the objective function has changed a little bit. And for the time being, uh, this is a funny assumption. In fact, on records, I'll say that economics is one subject where the theoretical portion has a number of embedded assumptions. The moment you relax an assumption, you come up with a new theory. So this assumption is quite, I will say, preposterous, but for the slides, I'll say, okay, quite an assumption that the number of plants is continuous. This is nothing but for the mathematical simplicity of it. With n being a discrete number, you cannot have del q del n, right? But here you can. And that's the assumption. So just like a cartel, it will also equate marginal revenue coming from the inverse demand function to MCI. This I is nothing but the ith plant. And you'll get the same result because again, it's a joint profit maximization. Now, this part is exactly similar to the cartel part. So each plant of this multi-plant monopoly will produce this much amount. Look, this particular amount is contingent upon the very simple functional forms that we have continued throughout. The P is equal to A minus BQ. Q is the total quantity supplied. That's the inverse demand curve. And a total cost, which is F fixed cost plus C constant marginal cost into Q square. That's the functional form. So we have not changed that functional form. Now, in addition to what the cartel does, this multi-plant monopoly will also adjust n, number of, because then each plant would also operate at a minimum average cost. Now, what is the minimum average cost? This, how did I get it? From the monopoly. You'll find, just go back to the slides when you have the slides with you, you'll find. Now, the minimum average cost, you equate, you get the optimal number of plants also. Now look, all these A, B, C, F, whatever, these are numbers. The moment you have the exact values of say A minus BQ, so A is the intercept, B is the slope of the demand curve, and we have assumed a linear thing, it will not change. If you have a quadratic sort of concave or convex demand curve, it will not change, because look only at a particular point of intersection that we're interested in, where the demand curve meets the supply curve. And all these values will be there, right? So the multi-plant monopoly will have a fixed cost parameter in its profit maximization. Remember, in a monopoly, the choice of quantity was irrespective of the fixed cost. But if the fixed cost is higher, very high, the total profit might become negative and it could have chosen a zero output. But here, we'll also choose the number of plants, which is contingent upon the fixed cost. So it's already 5:58. So I think we shall stop here today. I guess it was quite a loaded lecture, too many things at one go. But once you have the slides and the reference, I have just kept one reference. So I don't think you'll have any problems. And also all the theoretical part are substantiated with a particular generic functional form, so that with any number or any other different functional form, you can do it. So that the applied part is also embedded in the slides. So I'll stop here and I'll just ask all of you to raise any doubt or question or anything that you have in your mind. The floor is open.